Alright, here is our next problem. So if you want to try this one on your own, that'd be great. So you might pause it and see if you can do the derivative and then pick back up. So what I would do is, this is a product rule again, so I'd have x and I'd have 5x plus 25 to the 1/2. Derivative of x is 1. Derivative here, I got to use chain rule. So I have u to the half, which is 1 over 2u to the half. 1/2 u to the negative half simplifies to that. So, derivative of u, we have 5x plus 25. Derivative of that is 5. So I'm going to multiply these. A lot of you made the mistake on your final of putting the derivative of u here. This just says u, it doesn't say u prime. So I'm going to put u back there, and I get 1 over 2 times the quantity 5x plus 25 to the half power. I'm multiplying that by 5, so I'm just going to put that on top. So if we crisscross, we have 5x. I wrote too big, I think. I'm going to write the derivative of that one over here. That way I can work it out. Alright, so this is 5x. If I crisscross that times that, and then we have that times that. And so plus 5x plus 25 to the half. Here's the hard part. This has a lot more x's in it than the last one did, so we're going to have to do a little bit more manipulation when we set it equal to 0. So remember, this was our derivative, so if we set it equal to 0, we're finding out what values of x make our graph have a horizontal tangent. So to solve here, since we have a denominator, we're going to have to multiply by that to get it out of there, because we can't solve with x in the denominator. So you can do that first, or you can do it last. I'm going to do it later. I'm going to move this to the other side. So I have 5x over 2 times the quantity 5x plus 25 to the half power equals negative the quantity 5x plus 25 to the half power. So, questions from there? I would write questions down to be able to ask in class. So, alright, from there what I would do is I would multiply by my denominator. If we multiply by our denominator, cross multiply it, we get 5x equals negative 2 times that. If they're to the half power and they're the exact same thing, you can add your exponents. And so you get 5x plus 25 there. Then, from there, what I would do is I would distribute this out. So then I'm going to come all the way back up to the top. So I would get 5x equals negative 10x minus 50. So I'm going to solve for x. So I got 15x equals negative 50. Divide by 15. And you get negative 3 1/3. So then, from there, you plug into your original, not to the derivative, because if you plug into the derivative, what are you going to get? 0. So we plug into our original to get our y value. And for y, we get negative 9.6225. So here's one of our answers. So we're going to put that up here, negative 3 1/3 and negative 9.6225. There we go, plus. Alright, so that was our critical number by setting our derivative equal to 0. But if you remember, at the very beginning of this section, I said the critical numbers can be where there's a whole or an asymptote. So we need to look at our derivative. If we look at our derivative, for what value of x would make the denominator 0? Since x is in our fraction here, we have to state where it's undefined. So what makes our denominator 0? And that is at negative 5, because 5 times negative 5 is negative 25, plus 25 is 0. So, at x equals -5, we have a critical number because it made our derivative undefined. If it makes your derivative undefined, that's bad. So we plug that into our original, not to our derivative, because if we plugged it in the derivative, you'd get undefined. If you plug it in here, you end up getting 0. So that is another solution, and it was a special case solution by looking at what made the denominator 0. In our last problem, we did not have a fraction for our derivative, so we didn't have to worry about where it was undefined at. Only if you have a fraction. Alright, number 3, it looks like we finally get off of the product rule and have to do the quotient rule. So why don't you try that one on your own? Low, derivative of the low, high, derivative of the high. Crisscross. I'm going to distribute, so minus, not plus, 2x squared minus 4x. The reason I'm subtracting is because you're supposed to subtract the whole back part. So here I'm going to simplify. So I got negative x squared minus 4x minus 4 all over the bottom squared. And that's my derivative. From there, you set your derivative equal to 0. So we got 0 equals our derivative. To solve for x, we are going to multiply by our denominator. So if I take 0 times that, I get 0. Then we have our numerator. Since it's quadratic, you have 2 options to solve for x. You can do quadratic formula or you can factor. I'm going to go ahead and factor. So we have -1. All of them have -1 in common. You have to pull out a -1? No. I didn't. You can tic-tac-toe or do an area model here. And I'd get x plus 2 and x plus 2. So here we got x equals -2 is a problem area. That means it's a high or low. So at x equals -2, we need to figure out what our y value is. And we plug in not to our derivative, because that would make it 0. We plug back into here. And if you plug into here, you would get y is undefined. So that means you either have a vertical asymptote or a hole there. So that is a critical number. Then we've done our derivative set equal to 0. So now we need to look at our derivative. Since our derivative is a fraction, what makes our derivative undefined? And a lot of you are going to say 2 and -2. So we get that answer again. You don't have to repeat it. But then we're going to say that y, if we plug 2 into the original, you get undefined. So there are your 2 answers at -2 and 2. So, alright, we got cosine squared x plus sine x. On this one, we are going to do derivative. We don't have any product, so we're going to go ahead and do that. Here we got cosine x squared, which is the same as u squared, which the derivative is 2u. So I'm going to write that as 2 cosine x. The derivative of cosine is sine, negative. So I'm going to say derivative of cosine is negative sine. I'm going to put negative there, and then sine x. Alright, derivative of sine is cosine. Here's our derivative. We set our derivative equal to 0. We don't have a fraction, so we aren't going to have to worry about figuring out where it's undefined at. So in this one, what do both terms have in common? They both have cosine in common. The 1 comes from cosine, divided by cosine is 1. So now we're going to set each factor equal to 0. So cosine of x equals 0, and -2 sine of x plus 1 equals 0. So we need to know the angles where cosine is 0. The angles where cosine is 0 are a lot of places. You can type in inverse cosine on your calculator and it's going to give you 90 degrees. That is correct. But it also happens at 270 degrees. And then it also happens at, what's 270 plus 180? No, 360, 450. And then it happens again and again. So it happens every 180 degrees after these spots. So we're going to say 90 plus 180 in, as you keep adding 180 to it. For this one, we are going to subtract 1 first. We've got to get sine by itself. And we're going to divide by -2, so you get a half. So if you type inverse sine of positive half, you would get 30 degrees. On your on your high dive test, I had you figure out where the sine value would be the same. And so there's lots of possibilities. Our other quadrant that has a positive sine value is the top 2. So if it's 30 degrees, we're going to have an angle over here as well. And its reference angle is going to be 30 degrees. So you get 150 degrees. And so this one's going to have some, and you just keep adding 360 to those values. So this one's going to have a weird answer of 30 plus 360 in and 150 plus 360 in. So it has 2 answers on that.